Yeah, so the computer will
Okay.
tell the floor on the truck to move material in, and then once it gets in, the material will be moved.
This is more or less kind of the holding area.
Yep.
Before it goes
And in winter, if we were to have this all full of our densified material, we'd probably have 2 or 3 days worth of storage, depending on how fast we're
in
going.
here. Okay.
Yeah.
And this is providing energy for, or is it the heating and cooling
This
needs,
provides heating and cooling for heating needs anyway, 80% of peak demand.
Okay.
So in the middle of January, when it's just bitterly cold here, we'll have to rely on some of our natural gas systems. But probably as your campus is, this is got a redundant system so that if one goes down, we have other backup systems. Yeah, initially though, we did try just putting bales on here, and there are some bars at the end that we'd hoped would break them up, but it just didn't work. So then we went to grinding material and putting it on here, and that didn't work. This is a main gasifier here, and you can see we've got that stuff in the bunker. It's moving this direction and then dropping down into the hydraulic ram. And then the ram is pushing it into the gasifier itself. Before I show you these are our student gasifiers. So we teach with these. For the last 2 years we've taught classes, and then we have students do projects with them. In fact, I've got an intern who's finishing up this project now. And these use all the same principles as a big gasifier, but a little more manageable for students.
Yeah, and I think this is what we're trying to get one of. I don't know if they're homemade here or
they can be homemade, but we get these from All Power Labs in Chicago, or in Sacramento.
Okay.
I believe. And they're about $2,500 a piece.
Oh, okay.
Right now.
Yep.
Now, when this thing jammed, yeah, you can kind of see through this window, but there's a little stuff in there. But when this jammed, we literally sent a bunch of people in there to hammer it out because it was tight in there. We had replaced this cylinder a couple of times, upsizing it each time, and it just couldn't do it. And so now we've changed the fuel, and that seems to work. Really fairly straightforward, it's just how much biomass, how much air, and then how the two meet and interact. So if you're getting a lot of air into your particles, they react faster. If there's more surface area where air can contact, they react very fast. That's why fluffy material is actually a problem for us, because this stuff reacts so fast, it causes problems. And we're also pumping air from underneath, and so it'll blow up, and it'll act more like some of your pulverized coal boiler systems. The reactions are taking place so fast.
You mentioned before the problems with the silicon. That's going to take your place inside the gasifier. So,
yeah, that's where it's getting too hot. Yeah. So yeah, the way we control the air is by the variable speed fan. We've got one there, and we've actually got one that pumps flue gas back in, because if you're using the flue gas, it doesn't have any oxygen. So it's kind of a filler air with no oxygen, and it'll give you the right blend of oxygen in there. But we've got some different fuel products here. And we've got some chopped up material here, which is one of our tests.
and that's the stuff you said is probably gonna. That's the 50% grass. And
well, this is actually all corn stover.
Okay.
It's what we tried first, and then we went to the 50% grass, and that seems to work better. So we've tried a lot of different things. Here's an example of what happens when it gets too hot.
Glass.
Yeah, that's slag. And that actually went all the way across, probably 5 feet across the inside, and 5 or 6 feet down the grade. And they had to they chopped it while it was still hot, so it broke up fairly easily, but that's a lot of work to get those out.
Yeah.
And then as it's gasifying, the gas is going up and into the boiler, and the ash is dropping out, and it comes through these chutes here out and back to a wagon out there.
Mm-hmm.
And we're hoping that we can get that back out on the field where the biomass is working. So you won't see it on this side as much, but since it is a research project, we do have a bunch of temperature sensors on the other side. You can see there's the one up there, but on the other side there's about 6 more of them. So we test pressure and temperature there. And the whole system is really regulated by airflow and pressure, air pressure in there. And so in the gas chamber itself, we keep a slightly negative environment. Mm-hmm. The one time we didn't do that, we had little puffs of smoke coming out all over the place. But it's just about, I think, 1/3 of an inch of negative pressure. Then once we get the gas off, it's starting to go up that duct. We have this fan here, which will add more oxygen. Okay. Once you add the secondary oxygen in there, it starts the combustion process. So they call this a close-coupled system because right after the gasifier, you start a combustion. There are a lot of gasifiers that do have quite a distance between where they use the gas and where they produce it. Now, one of the things in here, you notice the space here, well, there's also the space out there, and that was designed for research and teaching. And already we've put in our first, our first advancement in the project, or our phase 2 here, and that's back pressure steam turbine. That turbine will take our boiler steam and generate electricity with it. What we have here is that we have a boiler that will generate 280 pounds per square inch, and then it goes out to campus at 15 pounds. And we use that difference in energy to generate about 320 kilowatts of electricity. And so whenever the biomass plant is producing, we can be using that.
And that's energy for campus right away, or does it just go?
Honestly, most of it goes back into the heating plant here, just offsetting fans and equipment. One of the other things that we learned in this whole process is we took samples of corn stover to Illinois to a gasifier there to test out, and right away they told us there was a lot of chlorine in it, and that chlorine goes up the stack, and that's kind of a big problem because it joins with hydrogen, finds free hydrogen, or gets hydrogen in there and forms hydrochloric acid. And so one of the things that we didn't count on, that our consulting engineers didn't tell us right away, was that to mitigate that issue, we were going to have a large tank of 50% sodium hydroxide here. And so that's what this tank is, and we have to get deliveries a couple of times a year of 50%, which is like syrup. Let's see what's going on in there a little bit. You can get up close, get it. Get in there if you want. But yeah, that's the grate, and it goes back and forth to slowly push the material down.
I see.
That's another thing that we didn't really think about. The shape determines how fast it slides down. So bigger, chunky material that's prone to roll will probably roll down here, whereas small chips and things tend not to roll as much. And so we had to think about that. Now that we know a little bit more about the fuel, we're kind of having to consider things like that, speeding up or slowing down those grates in there to accommodate whatever fuel's in there. So in addition to the turbine downstairs, we put in an absorption chiller unit here as part of the phase 2. And what we did was we used an energy services contract to do some of this work. So we had an outside company put this in at their expense, but with the energy savings every year, they get a chunk of that money. And so we pay them off over time, and after a while the system is fully ours. And so this, you can see that the combustion air from the gasifier is coming through here. It's got air on the other side of the wall, so it's combusting and it's going through, and then it goes into the boiler.
Okay.
Now the boiler system is a conventional boiler. The only difference is it has a much bigger opening, because it needs that volume of throughput to get the energy to make the steam. Natural gas, you need just a small jet in there. Now once it goes through the boiler, we have a set of tubes. There's a duct out there that ducts the exhaust out, and we have a set of sample tubes that bring samples into this box. This is part of our USDA grant, which we put this in, and this monitors our emissions. So by law, we're not required to have this, but for research purposes, we thought it would be good to put this in, so we can monitor our nitrous oxides, sulfur dioxide, CO, CO2, and then our particulate matter. And one of the things we hope to be able to do is use our facility for companies that want to test materials, or if we want to do tests on materials, they can do it in our small system versus a big one. So that's what this allows us to do. This is also meant to be hooked up to the web so that other people can see the data. So if we are teaching a class, or if we have some researchers who are doing a project here, they can remotely access the information. And that goes along with the cameras and some of the other data. So I talked about the sodium hydroxide. We have a wet scrubber unit. So the flue gas is coming through, and there's a mist that's sprayed into it. And that mist will attract particles, and it will attract the chlorine that's going through. And so what we do is we put in a small amount of sodium hydroxide. We've got a pH meter that regulates that, and then the water is sprayed in there, and we produce salt is basically what the end product is. And then we also have a recirculating filter, and so we can send, every once in a while purge itself and send the material down the drain.
And this is providing energy for, or is it the heating and cooling
This
needs,
provides heating and cooling for heating needs anyway, 80% of peak demand.
Okay.
So in the middle of January, when it's just bitterly cold here, we'll have to rely on some of our natural gas. Yeah, so the computer will tell the floor on the truck to move material in, and then once it gets in, the material will be moved.
More or less kind of the holding area.
Yep. And in winter, if we were to have this all full of our densified material, we'd probably have 2 or 3 days worth of storage, depending on how fast we're going.
In here, okay.
It just didn't work. So then we went to grinding material and putting it on here, and that didn't work. This is a main gasifier here, and you can see we've got that stuff in the bunker. It's moving this direction and then dropping down into the systems. But probably as your campus is, this is got a redundant system so that if one goes down, we have other backup systems. Yeah, initially though, we did try just putting bales on here, and there are some bars at the end that we'd hoped would break them up. But